Hello friends, here is the problem. N to the power 4 plus 4 to the power n is never a prime number, or we can say n to the power 4 plus 4 to the power n is always a composite number. We need to prove this for all natural values of n. So before going to the proof, we'll understand the concept. To solve this concept is Sophie-Germain's identity. What is Sophie-Germain's identity? If a number can be represented in the form of a to the power 4 plus b 4 into b to the power 4, it can be written in this form, which is factorizable. So let me understand first how we can write this in this form. So a4 plus 4 to the power b4 is nothing but we can write a4 plus 4 b4. In between we can add 4a square b square and we can subtract 4a square b square. So this whole term, three terms, gives me a square plus 2b square whole square, and these terms become 2ab whole square. Further, since this is one term square minus another term square, so a square minus b square term can be factorizable. We can write a plus b, so a square plus 2b square plus 2ab whole into a square plus 2b square minus 2ab. So if any number can be represented in this form, a4 plus 4 times b4, we can factorize this number, this into this. So this number will be never prime, this will be always composite. So to solve this, we need to represent this number n4 plus 4n in the form of Sophie-Germain's identity. So let me start. So number is n4 plus 4 to the power n. So first case 1, suppose n is even number. So when n is even, we know any power of even, even to the power 5, 6 is always even. So this number n power 4 will be even, and also we know 4 to the power any even power 4 or any odd power 4, we don't care about n. So 4 power n will be also even all the time. So the sum of this is also all the time even. So for n being even, the given expression n power 4 plus 4 power n is always even. So now we need to check for case 2, n is odd. So when n is odd, we can write n is equal to 2k plus 1. Now put this value of n here. So n to the power 4 plus 4 to the power n can be written as n to the power 4 plus 4 to the power 2k plus 1. And how can we break this again? Which will be equal to n to the power 4 plus 4 to the power 2k into 4. So because this power is number. Now this is in the form of a4 plus 4 times b4. So we need to write this in the form of some power of 4. So here again we can write n4 plus 4 times, this will write 2 power 2 power 2k. So this all power will be multiplied, which will be n power 4 plus 4 times 2 to the power k power 4. Now this finally is in the form of Sophie-Germain's n4 plus 4 times 2 power k to the power 4. So a is equal to n and b is equal to 2 power k. So since this is in the form of Sophie-Germain's identity, we can factorize this, and hence for n being odd, this term is factorizable, means this term is composite and not a prime. So we have checked, and for even this term is not prime, and for an odd this term is again not prime. So this is the proof. Very simple.